In this problem, we're told the distance between two telephone poles is 50 meters. When a 1 kilogram bird lands on the telephone wire midway between the poles, the wire sags 0.2 meters. Draw a free body diagram of the bird. How much tension does the bird produce in the wire, and ignore the weight of the wire. So this right here is what's going on, right? We have these two telephone poles 50 meters apart. We have this bird on it, right? Sitting on a wire. The wire is going to sag 0.2 meters when they're on it. And the mass of the bird is 1 kilogram. Right, and so we also know, since it's in the middle, this distance right here, right, is going to be 25 meters. And the reason that is because it's just halfway, right? Halfway between the telephone poles. So just half of 50 is 25. So that's basically what we know. And the first part is drawing the free body diagram. So let's just go ahead and do that. So what are the different forces acting? So we have the force of gravity acting on the bird, right? Obviously. So it's just mg pulling it down, right? And then we also have two tension forces, right, in these wires, right? So I'll just call them T1 and T2. But that's not really going to make a difference. But yeah, so we have tension in here, going to be withholding, or like holding up the bird, right? Which is causing it so it doesn't just fall down, right? So how do we solve this problem? So the way we're going to attempt it is by taking the sum of the forces in the y direction. And I'll explain why we do that in a second, and you'll see why we do it throughout the problem. But the first thing you do is take some of the forces in the y direction. And so since this problem, or the bird isn't moving, right? It's static. The sum of the forces in the y direction equals 0. Because force equals mass times acceleration. Acceleration is 0 because velocity is 0. Okay? So what you do is you say 0 equals, and then you calculate the forces in the y direction, right? So what are the forces in the y direction? So the forces in the y direction, and when I say y direction, I mean along this line right here, okay? So we have mg, right? And so mg is going straight down. And so when things go down, we label it negative. So minus mg. And then we also have a y component of these tension forces, right? So the tension forces aren't in the y, but we can take the y component of their tension forces, okay? So you can imagine it like this, right? So there's going to be an x and y component of these tension forces, and we want to plug in the y component, right? And when we do that, you'll see how it works out, but we're going to be able to solve for the t values. Okay, so how do we find it? So how do we find the y component? So the way, right, imagine this triangle right here. I'm just going to redraw it right here. So actually, I'm going to do it down here. So this is that triangle, right? And so we have some angle theta, right? And we also know this is t sub 1, right? Because it's just this thing, right? So this is the hypotenuse, t sub 1, the force in t sub 1. So you just label the forces on this triangle, right? And what we're trying to do is solve for the y component, meaning I'm going to label this y. So we're essentially trying to solve for this right here, okay? But it's a force. Keep in mind, this is just a distance, so it's not what we're looking for. But we want to find y. So if we want to actually solve this problem, right, we know the sine of an angle, right, is equal to what? Sine is opposite over hypotenuse, meaning opposite is y over hypotenuse, which is t sub 1, and multiply both sides by t sub 1, right? You get t1 times the sine of theta. All right, and so now we got the vertical component, right, of this tension force, and that's exactly what we wanted, right? So because we're plugging in all the vertical forces, right, the vertical forces along the y, right? So the forces in the y direction. So what we can do now is add it, right? So it's just going to be plus t sub 1 times the sine of theta, right? But keep in mind, there's actually going to be two forces, right? So in the y direction, you have t sub 1 times the sine of theta, and then t sub 2 times the sine of theta. But what you should know is they're going to be exactly the same. And the reason this is because we're exactly in the middle. So you can just rewrite this as 2 times, and t sub 1 and t sub 2, I'm just going to call them t from now on because they're the exact same, right? Because they're in the middle like this, and it's how it worked out, right? So 2 times t times the sine of theta, right? So if what we're trying to do is solve for t, right? We want to find the tension in each of these chords, right? We need theta, right? Because we have m, we have g, we have, right? We have 2 sine, but we need theta, right? So how do we find theta? So theta in this case is going to be this angle right here, right? So we need this angle if we want to be able to solve for it, right? Because this angle is this angle right here. So the way we do that is by using a trig again, right? But keep in mind, we're going to use some distances they give us, right? So if we want to find this angle, right? Because if you have two angles or two sides of a triangle, you can use it by, or solve it using trig. So we know of our triangle, right? Which is this thing. This bottom right here is going to be 25 meters, right? We can see it right here, 25 meters because it's just halfway. And then the change in the up, right? It's going to be up 0.2 meters. So this right here is 0.2 meters, right? And so now that we have two sides of the triangle, we can solve it using trig. So we know trig, right? You should know SOHCAHTOA, TOA, right? So you got your three trig functions, sine, cosine, and tangent. And then keep in mind what we're given. We're given the adjacent of the angle and the opposite. So opposite and adjacent, OA, we're going to use tangent. So you can take the arctangent of your two sides, right? So you put your opposite, right, which is 0.2 over 25, and that's going to give you the angle, right? So this gives us the angle. You're going to take the arctangent, 0.2 divided by 25, and you'll get 0.458, and so on. I'm just going to round to 0.46. So 0.46, that's going to be our angle theta. So if you want to use the more exact, just use it, but I'm going to use the rounded. So now we've got the angle, right? And this angle was this. So now we have 0 equals minus mg plus 2t times the sine of 0.46, right? And now we have all the variables, so we can just solve for t. So moving this to the other side, mg is equal to 2t times the sine of 0.46 divide by 2 times the sine of 0.46, right? And so when you go ahead and do this, right, you'll get t equals, and you're going to have mg on top, right? mg over 2 times the sine of 0.46. Mass is just one of the bird, right? G is just going to be 9.8, right? Acceleration due to gravity, divided by 2 times the sine of 0.46. So go ahead and do this. So it's just going to be 9.8, and then divide that by 2 times the sine of 0.46. So when you do this, you're going to get it equals 610. So t equals 610.33 and so on. You can round however you want. So 610 I'm just going to do. So 610 newtons, that's going to be the tension in one of the cords, right? So how much tension does the bird produce in the wire, right? So keep in mind there's two tensions on each side. So the tension in one of the cords is just going to be 610, right? So that's going to be 610 newtons, right? So this is the tension, right? Keep in mind T just represents each of these, so T and T. But yeah, so the tension is going to be 610 newtons, right? So this is your answer, and hopefully you found this useful.